To add on to that, I would like to say the from the data perspective, right? What is the real intent of your ground grid, of your grounding system, right? The real intent of your grounding system is not to save your life. The real intent of a grounding system is to provide an alternative non-current carrying conductor under normal conditions. It's a non-current carrying conductor, not your neutral. It's just a grounding, unshielded, bare might be quite often conductor that allows fault current to return back to the source. That's what we're doing. And in the process of having that fault occur, that current is flowing through that conductor, and all conductors have a known resistance per footage. And so they have a resistance to them. And so as that fault current of 1200 amps flows through this copper wire or whatever you might have, 4-aught, it's going to generate a voltage. And that's your other problem, right? So the first problem that you're going to have is that you're going to have to get that current from the fault location back to the source. The second, that way you're not just sitting there humming some source, some load out there at fault voltage. And then the other reason for it is your ground grid testing. You want to check the grid and make sure that you have a low resistance to earth, because if it's going to build a voltage across those conductors, you want your grid to be at the same voltage as the earth you're standing on. So that way you are not at a different voltage and it shocks you too. So both of those are preventative measures to help facilitate the safety aspect of it. But ultimately, it comes down to trying to make sure that we can identify the faults. And the tests that we use are there to ensure the integrity of that grid, the fact that it has good continuity, and the fact that the grid itself is bonded to earth sufficiently enough for the fault current that it's installed at.
Yeah. I think it's worth mentioning as well, too, what the purpose of grounding is, which you nailed the big one there, right? Which is going to be limiting. If we go to NEC 250 and look at exactly what grounding is done for, you'll see the word limit and stabilize show up. And those are two separate subjects, but limiting those voltages during non-normal operation is the primary function, in my opinion, of grounding. Now, there are a lot of other functions out there, and it depends on what the kind of the system is, of course. We want to minimize common mode voltages, all sorts of other functions for grounding, but generally speaking, it is to limit and stabilize, limit our voltage during non-normal operations, stabilize during our normal operations. And it's critical, and this makes a lot of sense when you get into what the earth electrode connection is, but it's critical to understand that ground resistance is incredibly variable, not only location, but also time periods. So if we go through a wet season, of course, we know that we would think, at least I should say, that we expect it to be a lower resistance time for our ground electrode. We expect the resistance of that electrode to be lower. Generally speaking, that is true. However, I have learned through working with our customers and being in all sorts of parts of the world, that's not necessarily always the case. So there are extenuating circumstances here. One of the recommendations I always give to individuals that are responsible for putting testing plans together is non-annual testing. Don't test every February. Stagger your testing because the atmospheric conditions are changing. Secondly, as we move into different locations, the geology changes. Again, an example from here in North Texas, I have a very low resistivity soil, but if I drive just 45 minutes north, that soil starts to turn into oxidized iron, and I get that red clay we start to run into. It's this silty material, clay material that incurs a much higher resistance. And it's not that we did the test wrong. We just are testing a completely different substance. The earth is literally changing. So we have to validate that our design meets our specification. And that's really, I think, where we get into what is a good and bad value. And I don't like to engage in that conversation. We're going to refer to our specifications and our standards for those directions, right? Everyone thinks the NEC says 25 ohms. That's not the case, right? The NEC doesn't have a specification. It says 2 electrodes. 1 electrode can have 25 ohms. 2 can have any resistance you want to. That's why we don't see ground resistance testing done very often in just general purpose installed electrical systems. But, to really answer the question, what is the purpose of ground resistance testing? We want to validate that our design meets our specification. We want to maintenance test to make sure that we are still meeting our specification. Why we do these things, why we have these specifications, limiting voltage, stabilizing for operation.